Welcome back to Three Inquisitive Kids. On this channel, our goal is to help you improve your level in mathematics as well as to create a curiosity to learn more. My name is Karen, and this is the second lesson of our 8th grade math Unit 6 series. If you want, you can check out lesson 1 where we covered means in the playlist, and its link will be in the description down below as well. So let's dive into this lesson, median and mode. Chapter 6, understand the definition of medians and modes and learn how to find them. This is the second lesson of Unit 6. As you can see, we have means, median, and mode, analyzing the central tendency from statistical charts, and statistical dispersion. The two learning goals today are 1. Understand the meaning of the median and the mode. 2. Able to make a preliminary judgment on the data by combining the differences among the mean, median, and mode. Introduction. Karen scored 78 points in the math midterm exam. There were 30 students in the class. Out of the other students, one student scored 100 points, 4 students scored 90 points, 22 students scored 80 points, one student with a score of 2 points, and another with a score of 10 points. Karen went home and told her mother that her grades were above average in her class. Did Karen lie? And as you can see here, the mean of the scores of all the students in this class was 74.4 points. Did she lie? Does this make sense? Because we know that 22 students scored above her. But how come she is still above average in her class? Did she lie? I mean, this is true, but it doesn't seem right to describe this set of data. Now, this is where the median and the mode comes in. The table shows the monthly income of employees in a company. Here we see a table. The top row is the monthly income, and the bottom is the number of people that have that monthly income. So one person has $45,000 per month, one person has $18,000 per month, and here, for example, 11 people have $3,000 per month. So this is talking about the different monthly income values of employees in a company. Our first question is to calculate the average monthly salary of employees in this company. And 2, if the average calculated in 1 is used to reflect the monthly income level of all employees in the company, do you think it would be appropriate? Okay, so the only average we know so far is the mean, right? So mean, median, and mode are all averages. So first use means to calculate the mean of the employees in this company. All right, so this was covered in the last lesson. Again, if you don't know how to do this, you can review and click the link in the description down below so you can review the what we learned from the last lesson. So the mean of the monthly incomes of the employees in this company is $6,276. So that's the average. But would you say this is appropriate to reflect the overall monthly income of employees in this company? Well, personally, I don't think it makes sense because, this is in the 6,000, so that would go somewhere in between here, okay? Here, so there's 3 people that's greater than that, and here, what do we have? We have 22 people that are to the right of it, which in this case represents have less than. Doesn't make sense that the so-called average or mean is above 22 employees in this company. It does not make sense, right? So this is what we call extreme values in statistics. If you have a data set and you have all of a sudden you have 6, 7, 5, 6, 6, and then another 7, that's your data set. and then you add in two more values. You first have 4,000, and then you have 0. So these two extra values, they can be called extreme values in this data set. So when calculating the mean, usually the mean is very much affected by these extreme data. And here, $45,000 is the extreme value. So it pulls the mean all the way up. So this does not make sense. This should not be used to reflect all of the income levels of the employees in this company. So what else can? The average is far greater than the actual monthly wages of the vast majority of people, 22 people, but the majority of people should be the average, which in this case is not. What is the median monthly income of the company's employees, and how did you find this? So first, what is a median? A median is, say, if you have a set of data, say you have 1, 7, 9, 6, and 4. The median here is first line them up from least to greatest, or greatest to least, but I prefer to do it least to greatest. So reorganize them as this, and that middle number is called the median. Okay, so now you kind of know what the median is. Let's find it. Does the mean or median more reasonably reflect the monthly salary of the vast majority of the company's employees? What does the median represent in this question? In this question, the median represents the value that half of the incomes are higher than, but the other half of the incomes are lower than. So here, the median, you're finding that middle value in the data set where it's right in the middle. So half of the incomes are higher than it, and the other half are lower. So here's the definition of the median and the mode. Usually, if n pieces of data, usually n pieces of data are ordered from least to greatest. The middle piece of data, or halfway between the middle two data. So if you're saying just saying if you have something like this, you don't have a middle number here. So you would take these middle two numbers and then find their middle, which in this case would be 4. So that is the definition of the median. Now, what is the mode? Well, we call the piece of data that occurs the most frequently in a set of data as the mode of the data set. So, for example, in the data set 1333376973333, 3 would be the mode of the data set because it has so much occurrences in it. Think. To find the median, you must first arrange a set of data in the order of size, from small to large or from large to small. So here, fill in the blanks and use the definitions that we just learned about the median and the mode to find the median and the mode of these 4 data sets. The answer for the medians would be 20, 21, 21, and 3, 20, 20, 20, and 35, and 5. How did you find the median of a data set? So reflect on that. How did you find it? And can there be more than one mode in a data set? So this proves that yes, there can be more than one mode because we have both 20 occurred 2 times and 35 occurred 2 times. So the answer to the second problem is yes, there can be more than one mode in a data set. And how did you find the median of a data set? Well, again, you order them from least to greatest, and then you find that middle number or halfway between the two middle numbers. If there are extreme pieces of data in a data set, the median can reflect the overall level of the set of data more reasonably than the average. So not the average, the mean. So if you have extreme pieces of data in a data set, then use the median because that would give you more accuracy. What is the median of the following sets of data? Okay, pause the video to find, and then we will look at the answers together. Alright, so to find the median, first order and then check if there is an odd number of of data values or a even number, and then you can find. So median of 3 and median of 4.5. Example 1. In a men's marathon long distance race, the time, so by minutes, used to drive 12 runners is as follows. And we have 12 runners times here. What is the median time out of these times? Again, let's order them. Order from least to greatest, this is what we have, and the middle number is halfway between the middle numbers of 146 and 148. Therefore, the median is 147. The median times is therefore 147 minutes. So if the runner score is 142 minutes, what is his speed relative to the median time? We already know that the median time is 147 minutes. This means that around half of the runners were slower than 147 minutes, and around half of the runners were faster than 147 minutes. Since this runner's time is 142 minutes, meaning this runner is faster than 147 minutes, therefore this runner had a better result than half of the group of runners. So what is the overall definitions and properties of the median? We know that the median is a positional representative value, the middle number, and there is only one. If in a set of data there are extreme values, the median can more reasonably reflect the average than the mean. And if the median of a set of data is known, then we also know that half of the data is less than the median and the other half is greater than the median. Now let's do some more practice. Remember, even though you already have the definition in right, there's lots of risk that maybe your calculation is still not so strong. So you have to make sure you know what you're doing. The math teacher assigns 10 multiple choice questions for a pop quiz. The scores of how well the class did on the questions are shown in this bar chart. According to the chart, the median number of questions answered correctly by each student in the class is blank. So when solving this type of question, usually I like to just write all the data values and numbers out, order them, and then find the middle value. That would be 9. Example 2. Given that in the data set 10, 10x, 8, ordered from greatest to least, so this is already ordered for you, the mean and median are equal. Find the value of x and the median of the data set. Solving problems like this, we already know the formula, but we're kind of going backwards, and now we already know the relationship between the mean and the median, but we want to know what is this data value. So the first thing we can do is find the equation, plug it in, plug the known values in, known relationship. Okay, so we already know that the median and the mean in this data set is equal. And this is the equation we can set. 10 plus x divided by 2, which is halfway between 10 and x, that's the median, is equal to the overall average, meaning x is equal to 8. Substitute this into here, so the median of this data set is 9. Practice. In the set of data 18, 22, 15, 13, x, and 7, the median is 16. What is the value of x? So that would be 17. Here's the analysis. There are 6 pieces of data in this set, and the median is the average of the two numbers in the middle. Because 7 is less than 13, less than 15, less than 16, less than 18, less than 22, the two numbers in the middle must be 15 and x. So 15 plus x divided by 2 is equal to 17. That is, x is equal to 17. Can there be only one mode in a set of data? The mode of a set of data must appear in the set of data, and there can be more than one mode. For example, in 1, 1, 2, 3, 3, 5, the modes are 1 and 3. The mode is the data with the most occurrences in a set of data rather than the number of data occurrences, such as 1, 1, 1, 2, 2, 5. So in here, the mode is 1 instead of 3. Example 3. A shoe store has sold 30 pairs of a certain type of women's shoes in a certain period of time. The sales volume of shoes of various sizes is shown in the table. Can you provide the shoe store with an import with an import recommendation based on the data in the table. So here we have the size, shoe size, and we have the number sold. As you can see, 23.5 was the most popular size. As can be seen from the above table, the data composed of shoe sizes, 23.5 is the median. Its meaning is the 23.5 cm shoe size was sold the most. Therefore, it can be suggested that this store ships in more 23.5 centimeter size shoes. What else can you suggest for the shoe store restocking? The pie chart. Oh, so this is another very similar problem. The pie chart below describes the sales of a certain sportswear in size S, size M, L, XL, and XXL in a shopping mall. Please make a purchase suggestion for this shopping mall. Because the mode is size M, therefore it is recommended, and M is the most frequently bought size, it is recommended that it imports more size M sportswear. And next, import size S and then import size L. Import less of size XXL sportswear as that is the least most bought size. So here is the conclusion of all of this. What are the characteristics of the mean, median, and mode? They all describe the average of a set of data although from different perspectives. When calculating the so do not be confused. This is not average. This is mean. So when calculating the mean, all data are involved in the operation. It can make full use of the information provided by the data, but it is easily affected by extreme values, although it is the most widely used. The advantage of the median is that it is simple to calculate and is only related to its position in the data. However, it cannot make full use of all the information in all of the data. The mode is only related to the number of times it is repeated in the data. It cannot make full use of all the data information, and when the number of repetitions of each data is roughly equal, the mode often has no special meaning because, we already know that there can be more than one mode. So sometimes it doesn't give us what we're looking for, which is one number, one average of a set of data. Class summary. Median and mode. Medians, the middle number of a data set, or halfway between the two middle numbers. Modes, the most frequently occurring data. And the characteristics of the mean, median, and mode. This is very important. The mean is often the most commonly used, which means average. The median represents the middle value, and the mode represents the majority value. The two skills we learned today is to understand the meaning of the median and the mode, and able to make a preliminary judgment on the data by combining the differences among the mean, median, and mode. Now that you learned the 3 different ways to calculate the average of a set of data, stay tuned and subscribe so you get notified when we publish our next video, our next lesson, where we use the combined understanding of the mean, median, and mode to help describe and find information from different data charts. Thank you so much again for watching through Inquisitive Kids, and remember, stay tuned for our next